Good day, grade 11th. Today we are going to look at combined number patterns. Alright, so what happens here is that two number patterns will be combined either to form a fraction or they'll be combined just in one line like this one. So we are going to look at just two examples to expose you to those. Okay, so if you look at this fraction, sometimes you can get a number pattern that is in fraction form. So the first thing that we would do is just to check if the linear patterns, the linear pattern is linear, geometric, or quadratic before you can conclude that it is a combined number pattern. So I did my check. I did my check. I couldn't find a constant difference. I couldn't find constant ratio. So there's no number, there's no like constant number that I can use to move from one term to the next in addition or one term to the next in multiplication. So that is why I said it fails to be linear, geometric. And then I also tried to check if it is quadratic. Also, the second difference was not constant, so it fails to be any of these three. So now that means it is a combined number pattern. So if it is a fraction like this, usually the numerator will have its own pattern and then the denominator will have its own pattern. So if you are asked to find Tn, separate the number patterns, deal with the numerator, find Tn of it, and then deal with the denominator, find Tn of it. So that is what I've done here. I separated them. I did 1, 2, 3, 4, and then Tn for the numerator was just n. Okay, and then because the constant difference there is 1. And then I did the denominator. If I look at the denominator, the pattern there is 2, 5, 10, 17. Okay, and then if I do my first difference, I get 3, 5, 7, and then which then gives me 2, 2. So that means it is quadratic. Then the denominator gives me a quadratic number pattern. So I find A, B, and C like we did before. So this is equals to 2a, this is equals to 3a plus b, and this is equals to a plus b plus c. So these are my values for a, b, and c, which then gives me Tn, which is equals to n squared plus 1. Then, because we are asked to find Tn of the main sequence, this one, the main number pattern, so that means Tn is then going to be n from the numerator and then n squared from the denominator. And then, so that means this is what has been used to generate the terms of the sequence. Now you can check for yourself. Let's check this one. N here is 3. So the top will be 3. And then the bottom will be 3 squared plus 1. 3 squared is 9 plus 1 is 10. So that is okay. Even here, we've got 4. And then 4 squared is 16. 16 plus 1 is 17. So that is how the terms have been generated. So it would have been impossible for us to try and find Tn for the fractions, but when you separate them, then it becomes simple. Okay, so the next question that would be asked would be to find the next two terms. So the next n would be 5. So you write 5. And then at the bottom it will be 5 squared, which is 25 plus 1, which is 26. And then 6 squared is 36 plus 1 is 37. So that's how you would do questions like that. All right, and then number 2, combined on one line. Okay, so now we don't have a fraction. So you've got a sequence that will look like it is a normal sequence like we've seen before, and then you do your check. If you try to do, you check if it's linear. Okay, let's try to add. If I add a number here, I need to add 2. Now I need to add 1. Then again it's 2, then 1, then jumps to 5, then negative 2. So it is definitely not linear because the number keeps on changing. Okay, geometric. If I multiply here, I need to multiply by 3, and then now already from 3 to this one, you multiply by 4 over 3. So it's not going to give you sorry, it's not going, it's already, the number that you use from this one to that one is not the same. So it is not going to be geometric. And then it is also not quadratic. So that means again it is combined. So now you have to check the combination. Usually is it will jump a term like this, and then you find the relationship that is going on as you do the skipping. So from term 1 to term 3 you add 3, from term 3 to term 5 you add 3, 5 to 7 you add 3. So it means from 7 to 9 I'm going to add 3 as well. And then from second term to fourth term, you multiply by 3, and then multiply by 2, multiply by 2, multiply by, you could have said plus 2 here, plus 3, but now if you check, I can't do plus 3 to that one. So that means this one is geometric, the bottom one. So 3 times 2 is 6, 6 times 2 is 12. So that means 12 times 2 will give me the term that will follow, 10. So the first question is write the next two terms. So here it would be, the question wouldn't ask you to find the general, the general term, the nth term for the main sequence, but they would ask you to find maybe term number, like in this case, they asked us to find term number 55. Okay, so the next two terms, like we said, the one that will follow is 12 times 2, which is 24, followed by 10 times, 10 plus 3. 10 plus 3 is 13. Yes, 10 plus 3 is 13. Yes, so the terms will be like that. Okay, so term number 55. Okay, this one you have to be careful. Term number 55 of this sequence, the blue one. Okay, so first thing you must find out, term number 55 belongs to which? Does it belong to the red one or does it belong to the green one? Okay, so if you check here, these are odd number positions. This is 1, this is 3, this is 5, this is 7. So that means the term number 55 will fall into the red sequence. Okay, so that's what I was saying here. So it is on the 8-3 pattern, which is the red one, where Tn is equals to 3n minus 2. So that means the terms of this sequence will be generated by this, but the n has to be the correct position in that sequence. So we cannot just put term 55 here, because term 55 of the main sequence is not term 55 of the red sequence. What do I mean by that? This one is position 1 in the red sequence, okay, which is still position 1 of the main sequence. This one is position 2 of the red sequence, but it is position 3 of the main sequence. This one is position 5 of the main sequence, but it is position 3 of the red sequence. So that means term 55 would be a position that is less than 55 of the red sequence. So we need to find that position. So that's what I did here. I said 1, 4, 7. So these are the terms 1, 4, 7, and 10. So 1 was position 1 of the main sequence. Of this sequence. It is also position 1 of the main sequence. 4 is 2 of this sequence, and then it is position 3 of the main sequence. And 7 is 3 of this sequence, and then it is 5. So now we need to find the relationship between the positions. And if I check here, the relationship between this and that, the position is always 2n minus 1, the position. So to move from here to there is just 2 times 1, 2 times the position minus 1. So 2 times 2 is 4 minus 1, you get 3. 3 times 2 is 6 minus 1, you get 5. So that means for this one to be term 55, I needed to have a term 28. So 28 times 2 is 56 minus 1 will give me 55. So that means the term that would be term 55 of the main sequence would be term 28 of the red sequence. So I have to find get term 28 of the red sequence, which is 3 times 28 minus 2. Then how I use this formula here, using this formula. So 3 times 28 minus 2 will give me 82. So 82 will be term number 55 of the main sequence when it is term 28 of the red sequence. So you have to be able to separate the sequences and find the correct term. Okay, so please be careful. Term 55 will not be 55 of the main of the red sequence. It will be 55 in the main sequence, yes. Then you have to find the position of it. And as you can see, the positions on the red sequence are smaller than the positions of the main sequence. So okay, so these are some of the questions that you may find in test or in an exam, in addition to just a general quadratic number pattern. Okay, so please do exercise 2, number 1H, and then I'll send a picture of another question. You only just do 2.1 there. Okay, thank you.